Hello friends, today we are going to have a new altogether a new video for APSIM hands-on training. It has been so many months. I have received so many requests that we should have hands-on training. So I decided to go for a video which will show you um, how to use APSIM model. And how we can make simulations and all those things. So the thing is that when you download AppSim in your computer, you will get to see where they are. So I'm going to show you that when you downloaded the software in your computer, then you go for AppSim user interface, and when you go to AppSim user interface, then at that time it will open like this. Though there is a simulation tree here, but I want to tell you that when you open it, you go for new because you don't have anything with you to work on it. So you don't have file. So what you do, you go for building new simulation. When you go for building simulation, you'll find these examples. So from these examples, you can choose one of them according to your choice, because it is preferable, it is preferred to take, suppose you want to work on wheat crop. So in that case, you take continuous wheat simulation. So I click that one and I get this simulation tree where the name is continuous wheat simulation. You can change the name here. Suppose if you want, you can name it. So with the cursor here and rename it. Suppose your name is something like, suppose I keep it so when I say OK, now I got this the simulation tree name. And what I did, because I want to work on wheat crop, so it is I choose the continuous wheat simulation. So in that case, you'll find that because it is built-in simulation, you don't have to call all those things or something from um, or build something new. So what we do, so if you look at the simulations, as if you remember in previous presentations, what I mentioned that we need to have different components of simulations tree in AppSim. So if you look at this, the Midfile, so it is somewhere the examples already said here. Midfile, something like that, good windy. So .Midfile, the extension is .Mid, and you'll find it is from 1940. You can drag down, 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 and you'll find it is 1942, well, 1989. So many years actually, because it is different. It depends on the availability of your climate data, the weather data, the minimum max temperature, solar radiation, and all those coming. You can see those things: solar radiation, maximum temperature, minimum temperature, rainfall, evaporation, and here the other things from the same raw data. After you make the Midfile, that we'll discuss one day how to make .Midfile for AppSim compatible to the AppSim software. You can see the rainfall chart. You can see from 1940 month-wise. Here, year only 1 year, 2 years, 3 years, 4 years, like that you can increase, and you can see how it works. Then you go for monthly rainfall chart, from 1940. Suppose for 1 year, you can see Jan, Feb, March, April, and year-wise distribution of rainfall. Then temperature chart, max and minimum temperature, then solar radiations, and in combination with rainfall, you can see when there is rainfall that drop in solar radiation because that day must have been very cloudy. So you see that this is what actually you get. Then what you get, clock means duration of simulation. If you want to go for 10-year simulation, then you see it is already default from that, because when you prepare your own, I will tell you something, but let's see this one first. You can take from this Midfiles and the duration simulation. Because the Midfile is from 1940 to 1981, you can change from here also duration of simulation. If you want, you can make it 1945 first Jan. It depends upon when you are sowing the crop. You can make it, suppose in situation like India, where it is month of June or July, we sow the crop due to onset of monsoon. In that case, you can change. I can change, or we can change, but it depends on your place where you want to work. And you can go for, why go for 5 year simulation? You can make it 1980, then 30 years, 40, 45 years, 35 years. You can make even 100 years, depend upon your climate file. Then, so here clock means you put the duration of simulation, how many years you want to go for 1 year simulation, or you go for multi years. I mean, like 5 years, 10 years, something like that. Summary file, you don't get summary file right now because you have to run it. Then probably you'll get summary file is the last thing we do. Then comes the paddock. We'll find everything here. In paddock, we'll find the soil file, then surface organic matter, fertilizer, then the wheat crop, wheat file, then the manager where you'll go for sowing to harvesting to all intercultural operations, then the output file where you get the output at daily basis, weekly basis, or monthly basis, or at the end of harvest, and different types of output. That output could be what variables you can put: day, month, biomass, yield means grain yield, grain protein, depends, and you can delete, you can add, and you can collect from here. Whatever this is mate content, mate means it is carbon dioxide, delta, all those things are here. If you change this to soil, you'll get a number of output files and variables. You can get the result. Similarly, for wheat crop, if you go, so you'll get biomass that we have already taken, then biomass nitrogen, all sorts of things, you can check from here. But I'll come to, without wasting time here, and reported frequency at harvesting, you can go for weekly or all those things from the clock you can take. So end of the day, end of the month, start simulation, start of the week, something like that, or you can uh, change it according to your device of output. So what I do here actually, so from continuous with simulation, I can name it either by right click it, or I can simply delete it and make it wheat. Suppose let's go for wheat, and wheat grain, your grain yield you are reporting, or you can write anything you want to. Then made file, I may take this one, but I can browse. I can see that I'll take something from my own. Suppose if I go there, I have my own APSIM file, then probably suppose I go for this BPL met. I have already generated this one. You can generate your own met file, and I changed it, and you can see the raw data. It is from 1980 to 2013, but it depends upon the availability of you know climate data or weather data. You can see the chart, the monthly chart, then temperature chart, the radiation chart, then clock. Since the raw data is from 1980 to 2013, probably I will go for, suppose, clock. I will set here maybe 1980, let it be, and we'll go for somewhere, let it be maybe for 10 years, 1990. So this is the duration of my simulation. So what I did, I chose the made file, I chose the clock. That means the weather file is ready and duration of simulation ready. Then comes the paddock summary. As I told you, will go at the end. So here, let's see at the initial water content. Usually it depends on how much water you want to put. 100% full, fill from the top, or if you want to make it evenly distributed, you can make 10% evenly distributed throughout the profile. And suddenly you'll see it is evenly distributed. You can keep that one, or specifying the depth, how much centimeter of wet soil, or specifying the plant available water capacity directly. So it's up to you how you are specifying. Suppose let me specify 10% of the total full maximum available water evenly distributed throughout the profile for initialization of the simulations. And here I'm not putting anything, I'm just making, so I'm, I'm taking the default soil to show you that the soil depth is up to 2 meter, having bulk density. These things, if you have your own bulk density, simply you can click it and change it by yours. You can change the depth, the interval also. If it's 0 to 10 or 0 to 5, you can make it also. If it is 15 to 30, it is 30 to 45 or 30 to 40, something like that. There is nothing wrong. You can edit anywhere, any part according to your choice. So what we'll do, so you can put your own data set here according to your properties of your soil profile, then air diet, then lower limit means it plant, permanent wilting point, PWP or percentage. Then drain upper limit is the field capacity, SAT is the saturation, and we can find the wheat curve here having all those values. Plant available water capacity, how much water, plant available water capacity, how much water available for the duration of simulation. Then KL value and accepts root factor, and we'll talk details about this one day, but I am talking the default one, how to run the simulations. Then the surface organic matter, you can similarly, so same depth is maintained here, just like previously whatever you saw here. The surface organic matter also organic carbon and the distribution of different pools of carbon accordingly, according to the value you put here, accordingly it will change because they depend upon the organic carbon content. And F biome is a fresh biomass carbon inert, then in kg per hectare, and humus. So it is given. So it's up to you if it is 0.5% organic carbon or total. It's given total. You can convert it to Walkley black, multiply by 1.3, but it depends upon the type of soil. The values are different. But for universal purpose, 1.3 is multiplied here. So you can change it to Walkley black also. We'll look at this. If it make it Walkley black, it becomes 0.8580. And if I make it total carbon, it's now 1.04. So 1.3 is multiplied here. Similarly, I'm not going anything in details, and it's of no use at this stage. Initial nitrogen content, we can go. You can see the nitrate content is given in ppm. According to your values, you can change here also, unlike just like we changed for water and bulk density, all those things you can change here. It is editable, and you can convert this one kg per hectare also. So you can convert it to kg per hectare simply by right clicking it, or by simply right clicking it, you can make it ppm. It's up to you which way you want, so you can do it. So this is part of the things I'm talking about, some of the simulations. So fertilizer is required because through fertilizer module you are going to apply nitrogen in the form of urea or any other form. Then surface organic matter is gone. Now we move to wheat, but as such you cannot see the the variety. So what you need to do, you have to bring an init file from the standard toolbox. You can see, so simply you left click it, drag it and drop it on it. So now I will find this value. The init file has come. Now we can call our variety. So there are large number of varieties are available, but we can browse from here. So from browsing we go to where it is actually already there in the C. Then you can see the program files, then APSIM 7.8.810, or then from those models you can go for XML file, go to wheat. It's already there, the wheat XML file, then open it, then it gives the link. Now you'll see from here you'll have a large number of varieties already built in there. Or if you have see the varieties from Bangladesh, the varieties from different parts of the world, and if you say that if I am not sure whether my variety is there, then you can search from here. If I put Sujata, yes, there are two Sujata, Sujata 1, then GW322, another varieties, another variety from India. So suppose Sujata also, if you want to put, then you can see that variety is there. So now I can call or initialize the plant module for wheat, and I can call the varieties through this. Hope you understood the procedure how to get. So from standard toolbox, you bring this ini file, drop it here on wheat, then you click it here ini file, then browse from and go to the original file from where you can collect the information about the cultivar from the XML file. You can view it and refit it and thoroughly you can see. Then come to the management folder. Now the variety is ready. So for a crop to be simulated, so what you need, we need information from sowing to harvesting and the climate file. It is a soil plant atmospheric continuum. So soil information we generated, or we have information on soils, we have information on atmosphere. So I know information on plant variety, just like wheat variety we got. Now what we need to do, the management folder, where the crop management practice, all cultural practices, what you do on the field condition, that actually we have to check. So in that case, what I mean to say, so when you sow the crop, it's sowing to harvest. So at least you should have two things, sowing and harvesting. Then comes the intercultural operation. In intercultural operation, you find you go for what? You go for I mean to say fertilizing the crop. Then you go for irrigating the crop because it's a wheat crop. So in that case, and sowing duration, what time you are going to sow, sowing, harvesting, and intercultural operation, we'll see it here. So it is very, crop management, fertilizer and sowing, all those things are very common. If you want, you can keep it here as such, no problem. So we go to the management option for the toolbox. So go to common tax manager here. So in that case, what sowing, crop sowing using a fixed date or sorghum sowing, you can see all those things, sowing, harvesting, all those things. Sowing on a fixed date. So that means I want to sow on a fixed date. Suppose we put it here. So what is sowing here? First Jan. Look at this format. 1-Jan. It can be Jan, can be capital J also. But suppose in our case we go for 15th November. We sow the crop. Okay. So 15th November we sow the crop. The plant is, our crop name is wheat. Of course it is wheat. Then sowing density, it is not 10, suppose 120 plants per meter square you want to keep because it's highly densely populated crop. Then sowing depth 50 millimeter or 5 cm is fine. Cultivar name, as I mentioned here, since I brought that ini file here and search for all those cultivars from the XML file, and you'll find all those varieties are here. So look at those number of varieties all over the world. So I have my one variety, suppose I took Sujata here, and row spacing is not 550 centimeter, 500 millimeter, 50 centimeter. In our case is 22.5 centimeter or 225 millimeter. So what I did, sowing on a fixed date. When I want to sow, I want to sow the crop on 15th of November each year during this duration of simulation, the clock. And the crop variety that I want to sow is Sujata, and having plant population or density this, row spacing this, and sowing depth this. So when you sow a crop on fixed date, you have to put all this information. What next? The next is fertilizer sowing. So when you sow the crop, you have to apply fertilizer. In that case, it is okay. The crop is sweet when you are applying for sowing, and how much you are, because you know that we may apply all 150 kilogram or 120 kilogram nitrogen at the time of sowing, we can go for split also, but let it be I am applying 100% because I just want to show on the simulation I want to apply all 100% and in the form of urea nitrogen. Matlab nitrogen is applied in the form of urea which will be available after 24 to 48 hours after application. Now then what next we do? We go for, after sowing we go for harvesting. So you can go for harvest rule. You bring the harvest because sowing harvesting must be there. In harvesting it is the wheat, it should not be other crops, it's fine. So sowing harvesting is done, fertilizer I did, then I want to go for irrigation. So what I do, from the standard management practice at tax we can go for irrigation also, or you can from the structural, no it is not there. So from this management tax you can get from irrigation and or irrigation on event or irrigation on date or irrigation at the start of the week. Look at these different components are there, fertilizer on fixed date. So let me irrigation on a date, and I can drop it here, irrigation on a date. So it wants me or another also irrigation and fertilizer and fixed irrigation. Let me check it, it must be there. Irrigation deficit, irrigation event, irrigation on event. Suppose I want to irrigate by the time of sowing, so you can go for that comes fertilizer. You can delete straight away this one, irrigation fertilizer on event, fertilizer, this irrigation on event, this one you can drop it here. So irrigation on event I am going for irrigating at the time of sowing, because you know that all wheat crop that need a pre-sowing irrigation unless otherwise it is rain-fed wheat, or if enough moisture is available for sowing you don't need irrigation, otherwise you have to go for irrigation. Suppose you go for applying how much, suppose 60 millimeter or 6 centimeter of water at the time of irrigation. Irrigation efficiency depends upon what type of, if you are going for flooding, if you are going drip, if you are going for sprinkler, then let it be 1%, otherwise it will be 0.6, 0.7 to 1 or 0.6, 0.8, 0.9 depend upon the types of irrigation, methods of irrigation you are following. Then which crop? It is the wheat crop, and when you are applying it at the time of sowing. Now what we did, we sow the crop, we irrigate the crop at the time of sowing with fertilizer at the time of sowing. Then what next? We have applied all the fertilizer at the time of sowing, but you can change it actually. If you want to go for two splits, then fertilizer on fixed date also we can put. Suppose in that case if you want to take fertilizer on fixed dates, then you can go for which date you want to apply fertilizer. Otherwise, suppose just to show you the simulation, let it be fertilize at sowing, and I apply all the 20 kilogram of fertilizer just to show you. Otherwise you can go for 2-3 splits also depending upon when you want to apply the fertilizer. So what we got actually at this stage now, irrigation on the event, that means irrigation at sowing we have given, then you want to go for irrigation on different dates. So it is 15th Jan, 15th November we sow the crop. If you remember what time we sow the crop, so sowing of crop it is 15th November. Now you have to, we give one irrigation at the time of sowing, then we go for another irrigation. How many days? Maybe around 25 days from the date, about 20 to 25 days, that is at the crown root initiation stage. At that stage you can go for applying irrigation. So November 15 you just add another 25 days, roughly 15, so it is 10 of December. Suppose first irrigation, crown roots, then if you go for another 20 days interval, suppose next one, then you go for second irrigation at 30th December, then give a space, it is given, then another 20 days, maybe 20 dozen, maybe if you want to give another, suppose 10 dash 5, you can make it cap or small, depends, there's no problem at least. So amount of irrigation each stage, let it be 60 millimeter or 6 centimeter. So irrigation efficiency, we can put it 1 at this stage for the time being. It depends upon the type of irrigation you followed, then efficiency has reduced. Then what we did now, we got all those things covered. We sow the crop, we have a cultivar, we fertilize, we irrigate it, and we get at different dates and sowing. The next is, you look at this, that is fertilizer module is there, but there is no irrigation module. So we have to bring the irrigation module in this one, so that the irrigation part is taken care of. So when you show the when you run the simulation, just like your fertilizer module, irrigation module is there, so this event will be fulfilled. Now what we do, now we got the simulation tree where we have the weather file, then the time or duration of simulations, then we have the soil profile where we have put all those information about the soil, then we got the varietal information, then crop management practices. We don't need this one at this stage, crop management, we can delete this one straight away. What we sow, then we harvest, then we fertilize at the time of sowing, and we get the event at different depths. Now what we need output. So output variables, as I mentioned earlier, date, time or biomass yield, let it be a default. You can get from this menu anything you want from this, so you can bring it and drop it here, so another row will be generated. So it is like that only. So you can save in between, you can save here and give your file name whatever, suppose mm1 simulation, it is up to you. I'm just giving one example. Save it. I've saved it here, but you can save anywhere you like. Next is, variables, you got reported frequency at the time of harvesting. So my duration of simulation was for 1980 90 10 years, so reported frequency at the harvest. Otherwise, if you go for daily, and you can bring it from this place, end of the day, but it will be too many, but 10 years every day it will give you the output and it will be too much. So if you don't want this, then simply you can delete it by clicking right. Now, so what next is the generation of graph. Suppose if you want to run the simulation, then you need graph. So what the graph from the toolbox, again look at this graph, it is there on the bottom of the screen. Then from the graphs, you probably bring this one XY, drag it and drop it in the output. You can see, you can XY plot, simply I took, there are so many things you can look at this, there are n number of things are there, according to your choice you can bring it. So what I did, I got all the information. Still I am not sure whether there is any information missing here, but according to me, if I think that all the simulations are complete, means informations are completed for running the simulation, you can go for run the simulation here. If there is anything wrong in that, you can find, and there will be error, and we can find out the error where it is there. So but at this time it is running, it is showing 0% because I went for 10-year simulation. If there is anything wrong, then definitely it will show me here, there will be some error, but till now that means it runs successfully. So in that case, now two things you have to see in the output file. Simply you can click on this output and you see the biomass for every year, the grain yield, grain protein, grain, and estimated soil water and biomass nitrogen, nitrogen the biomass. This is all example I'm showing here that it ran successfully, and you can see from your summary file. The summary files you can find whatever information you put it here in the paddock, all those information will be here, and information about the soil profile, depth wise distribution of all those values or properties of soils that you have put in the profile for initialization of the model as well as running of the model. And you can see which date you have shown, when you have given irrigation, when you have you know given nitrogen. All those informations are here, and in summary also it got flowering day, when it went for flowering, and stover yield, grain yield, grain wet yield, and with moisture, without moisture, is there any stress or anything here you can also find. And similarly, so when it is give for 10 years, this first year, second year, like that, because the simulation was run for 10 years, so 10-year information will find it here. That means we successfully completed wheat simulations, and we go for suppose plotting, because you got the information here, and you, from this graph you can go for plotting. What is how to plot? See, the pink color is here x variable. Suppose put this date, click on the date, it coming to x, then coming to y again. Suppose you want to put yield, means grain yield, you can have multiple things, biomass yield, then grain protein, all those things, if you could, the values will be different, so let it be there, and simply click on the xy graph again, and you'll get this is the biomass yield and this is the grain yield for that. There may be some reason why this was not, the yield doesn't come up properly. There must be a reason, we can find out from the simulations. But at this stage, friend, I must tell you that this is the first video to show you how to build simulations and how to run the simulations, what are those components, what are those things required, and how to bring those into effect and successfully run the simulation. So thank you very much. Hopefully this will help you in learning something how to use APSIM model. And at this stage I must say that thank you very much for your kind attention.